Section 13.2 has to do with angles and angle measures. We're going to take these angles that we've been talking about and we're going to put them on a coordinate plane. So if you have an angle, obviously you have two rays and this is the angle that's formed. This side is called the initial side and this side is called the terminal side. What's formed between the initial and the terminal side is the angle that you're looking for. So we always put these angles, when we put them on a coordinate plane, in a standard position, which means the initial side is always on your positive x-axis. So if I want to draw an angle that has 110 degrees, understand this is a 90-degree angle, so I'm going to go 20 more degrees past that. So that would be a 20 degree, and this would be a 90 degree, making a total of 110 degrees. So this angle right here that's formed on my coordinate plane is 110 degrees. If I have a negative angle, I go in a clockwise way versus counterclockwise is positive. So I want to, here's my initial side, it's always on the positive x-axis, and I want to go 45 degrees, which is going to be halfway between there and there, but I'm going in a negative direction, so I go clockwise. 210 degrees, understand this is going to be 90 to here, this is going to be 180, so it would be 30 degrees more than my 180. Okay? So there's my initial side. So this angle right here is 210 degrees. Okay? All right, let's do a few of these. This is negative, so I'm going in this direction. If I get down to here, here's again, every one has a initial side on the positive x-axis. Down here is 90. I want to go 10 degrees more. So that's 10 degrees past your 90. 160, it's positive. All the way over to here is going to be 180. So it's going to be 20 degrees shy of 180. So that's going to be approximately 160 degrees. Remember, this is your initial side. Negative 220. I always start right here. And I've gone down negative 90, negative 180. So I have to go 40 past the 180 for this whole thing to be a negative 220. 70. I always start here. Straight up would be 90. That's a 90-degree angle. So I'm going to go 20 shy of that. So this right here would be 70 degrees. 180, initial side, terminal side. Positive 180 and negative 180 are going to give me the exact same thing. It's going to give me a straight angle, if you will. Negative 30. Negative, you're going to go clockwise, so I'm going to go 30 degrees down here. And that's going to be a negative 30. And those would be how I take an angle and put it on a coordinate plane. When I take angles and put them on a coordinate plane, I take into consideration a unit of measurement called a radian. A radian is, it actually has value to it, if you will. So pi radians is the same as 180 degrees. So halfway around the circle, if I'm going from here to here, is pi radian units. If I go all the way around the circle, so in other words, I start here and my angle goes all the way back to here, 2 pi is all the way around the circle, or 360 degrees. anytime I see pi, I know I'm talking radians. Pi over 2 is 90 degrees. So this is going to be pi over 2 radians. Okay, so if you think about it, this is pi over 2. This would be 2 pi over 2, which is the same thing as pi, okay, because 2 pi over 2 equals pi. Down here, or 270 is the same as 3 pi over 2, and then all the way around the circle is the same as 4 pi over 2, or 2 pi. So then we have to be able to change degrees to radians. We don't even have to have a coordinate plane to do that. I just have to do dimensional analysis on this. So this is in degrees, so I want degrees on the bottom and I want radians on the top. Well, I happen to know that 180 degrees is the same as pi radians. So I can leave that pi in there. I can take my calculator and go 45 divided by 180. And I can convert it back to a fraction. It's going to give me pi 1 over 4, or 1 pi over 4, or pi over 4 radians. So 45 degrees is the same as pi over 4. So if I was on a coordinate plane here, 45 degrees would be that angle right there, halfway between 0 and 90. So this is 45 degrees, or pi over 4 radians. Okay, 415, if I want to convert it to radians, again, 180 and pi, because remember top and bottom cancel out, so I want to be left with radians. This is dimensional analysis. So I take 415, divide it by 180. It's going to give me a decimal value. I'm going to go back to math. I'm going to hit fraction. It's going to give me 83 pi over 36, and that's going to be in radians. Do the same thing here. So I have 180 degrees on the bottom, pi radians on the top. So I have 160 divided by 180. Convert it back to a fraction. It's going to give me 8 over 9. Now, there's a negative here, so there needs to be an negative here. Negative 8 pi over 9 radians. So that's changing degrees to radians, but you also have to be able to change radians to degrees. You're going to do the same thing. This time, however, I have radians on the top, and I want to get rid of that, so I need radians on the bottom, and I need degrees on the top. Well, pi radians is the same as 180 degrees. So you can see I've just flipped these two because I want to get rid of the radians. The pi goes away, and I have 180 divided by 3, which is 60. So pi over 3 is the same as 60 degrees. Same thing down here. Pi radians go on the bottom. Degrees go on the top. Pi radians is the same as 180 degrees. So my pi is going to go away. When I work this out, it's going to give me a negative 270 degrees. All right, then you have such a thing called coterminal angles. Coterminal angles are angles that have the same terminal side. So let's say that I have, we'll do this one out here. Okay, if I have 135 degrees, I basically have 90 plus 45 more. Okay, this is 135. But if I add 360 to it, so I go all the way around the circle and back to it again, then I get a coterminal angle of 495 degrees. That is the exact same terminal side because I've gone all the way around and back to it. If I want a negative one, all I have to do is add negative 360 to it. So 135 plus a negative 360 is going to give me a negative 225. So that would actually be coming this way around the circle. And that's going to give me the same terminal side. So this is one positive, this is one negative. What about if it's written in terms of radians? Well, think about what I just did up here. I'm going to take 3 pi over 4, and if I want to add 360 degrees, 360 degrees is the same as 2 pi radians. Now, I need a common denominator. The common denominator is 4, so I have 3 pi over 4 plus 8 pi over 4. That's the same thing as 2 pi. So I'm going to have 11 pi over 4 radians. So there's another positive coterminal angle. To get a negative one, I would add negative 360 to it because I would go around the circle the other way. So I'm going to add a negative 2 pi to it. Again, common denominator. So this is going to be plus a negative 8 pi over 4, which is going to give me negative 5, oops, I don't know why I put it over 5, over 4. It's going to give me negative 5 pi over 4. Okay, so, and this is, again, this is radians. So here's a positive coterminal side and a negative that I got by adding 2 pi, which is the same as 360, and negative 2 pi, which is the same as negative 360. Okay, this is a little different and a little weird, but do the best job you can on your homework. Page 784, 20 through 46 even.